Welcome to my channel. Am I audible? Can anyone just mention in the chat box? Is my voice audible? Okay. Okay then. So in this session, we will discuss electrical analogous of mechanical translational system. So we know in electrical system, there are two types of inputs. Oh, I will take the laser. Oh, yeah. In electrical system, we know there are two types of inputs. The input can be either voltage input or current input, or we can say there are two types of sources, current source or voltage source. Therefore, we can get the electrical analogous of the mechanical system or mechanical analogous of mechanical translational system. Here, I am going to discuss only mechanical translational, not rotational. So, electrical analogs of mechanical translational system. So, we know the input for mechanical translation system is force, and for electrical system the input can be either voltage source or can be current source. Therefore, there are two types of analogies. One is force voltage analogy and force current analogy. Okay, so let us discuss one after another. So let us start with force voltage analogy. So let us first start with the mechanical system, mechanical translational system. We know there are three basic elements of mechanical translational system. Three basic elements of mechanical translational system, which are mass, frictional element, and spring. So here you can see M is the mass and B is the frictional element, that is dashpot. And this is our spring, which is represented by frictional elasticity coefficient, that is K. So you can note it down in your notes. So this is all the three basic elements have been mentioned here. This is our input, that is force, and let us assume there is a displacement of x here. Okay, so you can copy down this diagram in your notes. So if we have a mechanical translational system, which is shown here in this diagram, if you have a mechanical translational system, for that mechanical translational system, we can write down the force balance equations. So in order to write the force balance equations, we follow the law which is known as Newton's second law. So by Newton's second law, this is our applied force F, that is equal to m into d square x by dt square plus b into dx by dt plus k into x. So this is our force balance equation. So just take a minute, just write it down in your notes. Draw the diagram, and by Newton's second law, this equation you just write it down. And if you are able to convert this force balance equation, which is in time domain, into Laplace form, then you just convert it and you just write down that also. So I hope you have written. If you complete, you can just simply type completed so that I will come to know and I will change the slide. So it's simple, isn't it? So what do we want now? We want force voltage analogy. For that, we have taken a mechanical translational system in which all the three basic elements of mechanical translational system are there: mass, dashpot, and spring are there, and applied force F. For that, we have written differential equation up using Newton's second law. That's it. So I'm going to change the slide now. For that differential equation, if you convert that into Laplace form, what do you get? F will, instead of small f, you will write capital F of s is equal to m into, what was there in differential equation? M into d square x by dt square. Instead of that, you can write m s square x of s plus b s x of s plus k x of s. Consider it as equation 1. Okay. Now, this is our um, what to say, force balance equation in Laplace form. That equation 1 is the force balance equation in Laplace form. Now let us consider electrical system with three basic elements. What are the three basic elements of electrical system? Resistor, inductor, and capacitor. What is our source? Here we have considered force voltage analogy. So our source is what? Voltage source here. So our source is voltage source. You can see there is in this diagram, you can see this diagram. This is our voltage source V, and resistor, inductor, and capacitor. Okay, I will just erase all the ink. I will take the laser. So this is our electrical circuit with three basic elements R, L, and C. Our source voltage, voltage source is V, and because of this voltage source which is connected across these three elements, I amperes of current flows through, small I amperes of current flows through R, L, C. Okay, so this is small v and this is small I. Okay, now applying KVL. Now applying KVL, you can write down the differential equation. V is equal to R into I plus L into di by dt plus 1 by C integral of I dt. Okay, so this is our differential equation. Applying KVL for this circuit, we have written this. Now apply Laplace transformation. Okay, so applying a Laplace transform to the above equation, V will become what? V of s. R is constant, keep it as it is. I becomes I of s. L is constant, keep it as it is. Di by dt is what? S I of s. Plus 1 by c, you just keep it as it is. Integral of I dt you will get I of s by s. Okay. So this is our equation 2. Just write it down, whatever is visible on the screen in your notes. I'll give you a minute. So I hope you have written. So if you people are copying it down, if anyone, just mention in the chat box so that I can proceed further. You just mention completed. Okay, now let us, we already know what is current. You can write current in terms of charge. Relation between current and charge is what? I is equal to dq by dt. You just take the Laplace transform of this I is equal to dq by dt. So I will become Laplace, considering the Laplace of I equal to dq by dt. I is Laplace of I is I of s. Okay, and Laplace of dq by dt is what? S into q of s. Laplace of dq by dt is s into q of s. So it's simple. I is equal to dq by dt. We already know relation between charge and current. Okay. So I equal to dq by dt. Take the Laplace of the above equation. Instead of I, you write I of s. Instead of dq by dt, it is what? S q of s. This is our equation 3. Now substitute this equation 3 in equation 2. Okay, that is our the voltage equation in Laplace form. In that, wherever I is there, I of s is there, you just write s q of s. Okay, so if required, see, I will just copy and I will just show you that equation also. This is it. This is the equation which was in the previous slide. This equation. I will just put it in the bracket so that you will not confuse. So this was the voltage equation, isn't it? Applying KVL, we wrote the differential equation. After that, we by applying Laplace transformation, we got this equation. Now here V of s is there. You keep it as it is. V of s is equal to R is there. You just keep it as it is. I of s. What is I of s? I instead of I of s, right? S q of s. S q of s plus. Okay, plus L is there. Write it as it is. S square, here S is there. Okay, you can write S as it is. Instead of I of S, what you should write? S Q of S. So already S is there. S into S Q of S, it will become S square Q of S. Plus 1 by CS is there. You just write it 1 by CS as it is. Instead of I of S, write S Q of S. S Q of S. Okay, so this was the equation in the previous slide. So we have substituted this equation 3. This was our equation 2. This was our equation 2 in the previous slide. So in this equation 2, I have substituted equation 3. So if you substitute it, you will get this equation. Okay, you will get this equation. Now if we observe here, this S and this S will cancel. What is left over? V of S is equal to L S square Q of S plus RS Q of S plus 1 by C Q of S. Okay. So simply what I have done is first I have written S square term, later I have written S term, and after that I have written S power 0 term. I can say S square, S power 1, S power 0 is nothing but 1. Okay, so in that pattern I have rearranged the terms I have written. If you don't want, you no need to rearrange and write like this. If you want, you can write it. I have written certain sequence. S square first, next S power 0 term. Okay, so this is what you will get. I hope you have understood. If you want me to repeat, in the chat box you can mention repeat. You just type repeat so that I will repeat it. Okay. If any slide, if you are unable to follow, and if you feel difficult, I will explain once again. So you just copy it down. I will just erase this upper one, whatever I have copied from the previous slide, this equation. I will remove it. You people just note it down in your notes. It's very clear, I think so. So someone has mentioned to repeat, so I will repeat it. I will once again repeat it for the sake of, okay, I will start with the beginning. Shall I start with the beginning? Force voltage analogy. So I will start with the beginning. So force voltage analogy, someone has mentioned to repeat, that's why I'm repeating. So see force voltage analogy. So here we want to, so as I have already mentioned, there is a similarity between mechanical system and electrical system. Okay, how they are similar, that we are going to find out in this concept, how the mechanical system and electrical system is similar. So we already know that mechanical translational system, here I have mentioned only mechanical system. It might have been better if I have mentioned mechanical translational system. So it is mechanical translational system. Okay, so I have written only mechanical system. It's okay, even if you write mechanical translational or mechanical, both are same. So, okay, so this is our mechanical translational system, mass, frictional element and spring. These are the basic elements of mechanical translational system. F is the applied force. Okay, so I'm once again repeating for due to someone has asked to repeat, that's why I'm repeating. Others be patient, please. So this is the applied force F. So this is mass, this is spring, and this is our dashboard. These three are the basic elements. Let us assume x is the displacement, and by Newton's second law, we can write down the force balance equation. What is it? Applied force is equal to the sum of the opposing forces. What are the opposing forces here? Force due to mass, force due to friction, force due to elasticity. Okay. Opposing forces are force due to mass, force due to friction, and force due to elasticity are the opposing forces. So applied force, according to Newton's second law, applied force is equal to the sum of applied force is equal to sum of the opposing forces. So here applied, there is only one applied force F is equal to opposing force due to mass is m into d square x by dt square plus opposing force due to friction is b into dx by dt plus opposing force due to elasticity is k into x. Okay, now for this differential equation, you just take the Laplace transform of this above equation. If you take the Laplace transform, what do you get? F of s is equal to m into s square x of s plus b into s x of s plus k x of s. That's what you will get. So I will just show it in the next slide. So I hope you have understood. Okay. So f of s is equal to m into s square x of s plus b s x of s plus k x of s. Consider it as equation 1. Okay. So we have taken a mechanical system, translational system. We wrote the force balance equation applying Newton's second law, and we have determined the Laplace of that force balance equation. Now consider an electrical system. The basic elements of electrical system are R, L and C. R, L, C are the basic elements. So here it is force voltage analogous system. So force voltage means here our source should be voltage source. So source is voltage source. Here you can see voltage source. Our voltage source is connected across RLC. Okay, resistor, inductor and capacitor. So voltage source is connected across RLC here. So because of this voltage source, current of I amperes flows through these three elements. Okay, current of what is it? I amperes flows through these three elements. I'm erasing all links. Okay. Now by applying KVL to this circuit, we can write down the differential equation for this circuit. So what is it? V is equal to, what is it? Wait. Uh, V is equal to R into I plus L into di by dt plus 1 by C integral of I dt. So whoever have joined this class, definitely they might be the electrical students. So you might also always you might be knowing this equation already. So V is equal to what? R into I plus L into di by dt plus 1 by C integral of I dt. So applying Laplace transformation to the above equation. So by Laplace transformation, what do you get? V becomes V of s plus R is constant. So leave it as it is. R. I becomes I of s plus L is constant. Write L as it is. Di by dt is S I of s. 1 by C, you just write it as it is. Integral of I dt is I of s by s. Okay. So you will get this equation 2 by taking the Laplace transformation of the above equation. So what do you get? V of s is equal to R into I of s plus L S I of s plus 1 by S I of s. Okay, so this is our equation 2. So we have two equations now, equation 1 and equation 2. So let us proceed further. We already know the relation between current and charge. I is equal to dq by dt. We already know I is equal to what? Dq by dt. So take the Laplace transform of this I is equal to dq by dt. I becomes what? I of s, and dq by dt is Laplace of dq by dt is sq of s. Okay, so Laplace of I is I of s, Laplace of dq by dt is sq of s. So substitute this equation 3, consider it as equation 3 and substitute it in your equation 2. So if you substitute this in your above equation of differential equation of that electrical circuit, whose Laplace form you have determined, what do you get is V of s is equal to R S Q of s plus L S square Q of s plus, okay, I will copy that once again. So this is our equation. What was the equation in the previous slide? V of s is equal to R I of s plus L S I of s plus 1 by C S I of s. Now what we have to do? We have to substitute this equation 3 in this equation 2. This was our equation 2. Okay, so in this we have to substitute equation 3, means instead of I of s you must write S Q of s. So write V of s as it is. V of s is there, you just write it as it is. On the right side R is there, write R as it is. Instead of I of s, what you must write? S Q of s. Write S R into S Q of s. L is there, write L as it is. Okay, here S is there, you can write S as it is. And instead of I of s, write S Q of s. So S into S Q of s means S square Q of s plus 1 by C is there, 1 by CS is there, write 1 by CS as it is. Instead of I of s, write S Q of s. S Q of s. So here you can see S is in the denominator, S is in the numerator, SS will cancel. What is left over is V of s is equal to okay, R S Q of s plus L S square Q of s plus 1 by C Q of s you will get. But I have written in certain pattern S square, next S and S power 0 term, means S is not there. Okay, S power 0 means 1. So L S square Q of s, above equation I have written like this: L S square Q of s plus R S Q of s plus 1 by C Q of s. Consider it as equation number 4. So someone, why Q of s? Why? Because why we are considering charge? That's what you want to know. That's why we want to know, isn't it? Someone has mentioned why Q of s. Why do you want, why instead of I? Why you are replacing I with Q of s? Why you will come to know soon. Why? Because what we are trying to tell here is that both, I'm sorry. Okay. Both the electrical system and the mechanical translational system, both are similar to each other. Okay, they have similarity. They are analogous to each other. Okay, they are analogous to each other. So electrical system and the mechanical translation system are analogous to each other. I mean they are similar to each other. So we want to prove it. Okay, we want to prove it that both are similar to each other. How they are similar to each other? In order to prove that, we have replaced I with Q. Why we have replaced, you will come to know soon. Okay, at the end of this derivation, whatever I am doing here, explanation, at the end of this derivation, you will come to know. When you get the last expression, you will definitely come to know. Okay, so don't worry at present, just follow me. Whatever I am explaining it to you, just listen to me and okay, just listen to me. You need not worry. At the end of this session, you will be clearly able to understand why I have replaced I with Q. Okay. So why I have replaced current with charge. Okay now. So I was just giving explanation for someone who has mentioned why Q of S. It's better I will keep it in front of me. Mm. Okay then. Mm. Okay, now there is an equation 4 and there was equation 1, isn't it? There was equation 1. Okay, so I'll just copy the equation 1 in the other slide. Wait a second. In order to give the answer to the person who has asked or something. So this was our force balance equation in Laplace, isn't it? This was our force balance equation. He was asking me why Q of S. The answer lies here. You just compare equation 4 with this. This was our equation 1. Okay, you just compare those two equations. If you compare, you just see there is a coefficient besides to s square L. There is a coefficient. You just will just take the pen. There is this is s square s here s power 0 in this last s power. Okay, here again s square. This is our voltage equation, electrical equation. Okay, this is our mechanical equation. You just compare this. This was our equation 1. On not maybe it was 1 or 2. It was 1. Okay, it was 1, equation 1. Yeah, it was our equation 1. Okay, now just compare these two. This is s square, this is also s square. Here s is there, s is there. Here s is not there, not there. Okay, so here you can see there is a coefficient for s square L. Here coefficient of s square M. S square into Q of S, here X of S. Here coefficient of S is B, here it is R. Sorry, here it is R, here it is B, Q of S, X of S. So 1 by C, here K, Q of S, X of S. Okay, so and in the electrical system V of S, in mechanical system F of S. So whoever has asked why Q of S, can't you see that these two equations, this equation and this equation, aren't they similar to each other? You just mentioned in the chat box. Are they similar? Others can also mention. Aren't they similar to each other? They are looking similar to each other, isn't it? So when we replace current with charge, we are getting electrical equation. Okay, of course in Laplace form. When you compare the electrical voltage balance equation, we can say, which is in Laplace form, with the force balance equation in Laplace form, when you compare these two, both are similar to each other, isn't it? Okay, so both are similar to each other. So can I say that V is analogous to F? Analogous means what? Similar. Okay, I will erase all links here. So V is analogous to what? F. So in mechanical system, if F is there, in electrical system, I can replace. In mechanical system, F is there, force is there. If I want the similar electrical system, I can replace F with V. In mechanical system, if M is there, I can replace M with what? L. In mechanical system, if B is there, I can replace B with what? R. In mechanical system, if K is there, I can replace K with 1 by C. In mechanical system, if X of S, means if X is there, X of S is it is in Laplace, okay, leave it. If X is there, X means what? In mechanical system, X means displacement. Okay, X means displacement. Okay, X means displacement. In electrical system, what is similar to X? Charge, isn't it? Charge is similar to X. One second. So this is it. So you can prepare a table, and in that table you just copy it down. Whoever is noting it down in their notes, you just note it down. So V is analogous to F, L is analogous to M, Q is analogous to X, R is analogous to B, 1 by C is analogous to K. Okay. So I hope you have noted down, whoever is noting it down. So we can prepare a table. Okay, you can prepare a table and you can write mechanical system and electrical system. Okay, so F is analogous to voltage. Okay, you can write like this: F force is analogous to voltage. Okay, so X is analogous to Q. Okay, charge is analogous to, sorry, X is displacement. Displacement is analogous to Q. If X displacement is analogous to Q, then dx by dt is what? Velocity, isn't it? Dx by dt is velocity. dq by dt is current. So velocity is analogous to current. Okay, velocity is analogous to current. Next, frictional coefficient B is analogous to R, M is analogous to L, K is analogous to 1 by C. Okay, Newton's second law is analogous to what? Kirchhoff's voltage law. Okay, so this lever and transformer, this you don't require, you just leave it. So whoever is noting it down, you can write down from here to here. Just copy it down from here to here. So whoever is copying it down, no need to draw the table. You just write down mechanical system, electrical system. Just copy it down from here to here. If you complete, just mention that you have completed. So I hope you have understood force voltage analogy. So the thing is, you must remember to solve the numerical problems. To solve the numerical problems, you must remember the analogous terms. Okay, all these analogous terms you must remember. Then only you will be able to solve the numerical problems. Okay, did you complete? No need to write this item and all, because item you need no need. Okay, you just write mechanical system, electrical system, write their relation with means analogous elements besides to each other. Shall I change the slide? Can anyone mention in the chat box? So I'm changing the slide. So now let us see the force current analogy. Okay, we have seen force voltage analogy. Now let us see force current analogy. So same here also I will just write the translational. It will be more clearer, isn't it? I will write, we have considered a mechanical translational system. Okay, so I have considered mechanical translational system here. All the basic elements are here. Mass, dashpot and spring are there here, and applied force F. Okay, so this is our applied force. M, B and K are there, and displacement is X here. So someone has mentioned 1 minute. So for a minute I will just go back. Okay, someone has mentioned 1 minute, so I will just for a minute. Someone is still copying it down. So okay, I'll give you a minute. You just copy it down quickly. Okay then. So now let us see the force current analogy. Let us consider mechanical translational system. Once again, same mechanical translational system which I have considered for force voltage analogy. So here are basic elements: mass, dashpot and frictional element is, dashpot and elastic element spring is there. So applied force is F. So by applying Newton's second law, you can write the differential equation. So what is it? F is equal to m into d square x by dt square plus b into dx by dt plus kx. Okay. So same equation. Apply Laplace transformation and write down the Laplace Laplace equation for this. That is f of s is equal to m s square x of s plus b s x of s plus k x of s in Laplace. So just write it down. As soon as you complete, just inform me so that I will change the slide. So same thing which is already there, if you are copying it down in your notes, then it is already there in your notes. The same mechanical translational system I have taken. Okay then, completed. Okay. Okay. Is there any disturbance? If any disturbance is there, just mention in the chat box. So f of s is equal to m s square x of s plus bs x of s plus k x of s. That's what you will get for the above equation, force balance equation. Okay. Now let us consider the electrical system. Okay. So this is our force current analogous system. Force current analogous system means here, since we have mentioned current, That means our source is current source. So our source is, you can see here. Once again, I have taken three basic electrical elements R, L, C, and I have connected a current source. And since we have connected the current source, I have connected all the elements in parallel. Okay. So R, L, C are connected in parallel here, and current source is connected across all these three elements. So current of I amperes is it will flow through this circuit elements, and these elements wherever they are meeting their meeting point, okay, or that is junction, okay, or the wherever they are meeting, that is the junction. At that junction, the node voltage is V, and wherever, once again, another terminal is the reference node, that is 0 volts. Okay, so one is the node where current will distribute, and at the other node all the currents will add up and return back to the source. So at the node where all the currents will add up and return back to the source, that is our reference node, and the voltage at the reference node, we already know it is the 0 volts. 0 volts. Okay, so this is our node voltage V, and the current that is divided here in all these three branches. Source current is I, and the current that is divided here in all the three branches is current flowing through R is IR, current flowing through L is IL, current flowing through C is IC. So applying KCL for the given circuit, what is I? I is equal to IR plus IL plus IC. Now let us write down the nodal equations here. I is equal to IR is what? V by R plus IL is what? 1 by L integral of V dt plus IC is what? C into dV by dt. So this is our differential equation applying Kirchhoff's current law for the given circuit. Now apply Laplace transformation to this equation. If you apply Laplace transformation to this equation, what do you get? I of S is equal to 1 by R into V, isn't it? This V is the variable here, R is constant. So R is constant. So 1 by R into V of S plus 1 by L. Integral of V dt is what? 1 by S V of S plus C into dV by dt is what? S into V of S. This is our equation 2. Okay, so this we already know by applying Laplace transformation for this nodal equation, that is I is equal to V by R plus 1 by L integral of V dt plus C dV by dt. What do you get? I will become I of S. Here 1 by R is constant, 1 by R just leave it as it is, and V of S, V will become V of S plus 1 by L, write it as it is. Integral of V dt is V of S by S. So that's what we are written here. C is constant, write it as dV by dt is S into V of S. That is our equation 2. Okay, just take a minute, draw the circuit and write down the equations. If you complete, inform. Okay then. Now we have written the nodal equations for this electrical system, and we already know a relation between voltage and flux. V is equal to d phi by dt. We already know that phi is the flux. Okay, so I is equal to V is equal to d phi by dt. So you can replace V with what? D phi by dt. So first of all, convert V equal to d phi by dt into Laplace form. So V will become V of S. Phi will become what? S into phi of S. Okay. S into phi of S. So V of S is equal to S into phi of S. Now substitute this S phi of S in the above equation 2. I will just copy that above equation in this slide. So this is our equation 2. Now I of S, you just write it as it is. 1 by R, write it as it is. Instead of V of S, what we should write? Instead of V of S, what we should write? S q phi of S. Instead of V of S, write S phi of S plus 1 by Ls. S. I'm sorry, I should look at here. 1 by Ls, 1 by Ls, write it as it is. Instead of V of S, write S phi of S plus C, I write as it is. S into, instead of V of S, write S phi of S. So S into S square phi of S you will get. And you can see here, in the numerator and denominator here, again S is there, so you can cancel S. What is left over? 1 by R S phi of S plus 1 by L phi of S plus C S square phi of S. Okay, so this is what you will get. You can rearrange the terms. You can write S square term first, then S term for next S power 0 term at the last. So what are you getting here? So what are you getting here? Our equation number 4 is what? Equation number 4 is I of S is equal to C S square phi of S plus 1 by R S phi of S plus 1 by L phi of S. I of S is equal to C S square phi of S plus 1 by R S phi of S plus 1 by L phi of S. These are equation 4. So what we can do, you can compare this equation 4 with what? Equation 1. I will copy that equation 1 here. So I will copy equation 1. Where is my equation 1? This is here. This is equation 1. Okay. I'll put it in a bracket. This is our equation 1. Now compare this mechanical translational system force balance equation, which is in Laplace form, with this nodal equation of electrical system. Okay, just compare it. So f of s is analogous to I of s. M is analogous to C. Okay, M is analogous to C. X of s is analogous to what? Phi of s. B is analogous to what? 1 by R. X of s, phi of s, that I have already told you. K is analogous to 1 by L. Okay. So if you have a mechanical translational system, if you want to replace with electrical system whose source is current source, then instead of f of s, you can write I of s. Instead of M, you can write C. Instead of X of s, you can write phi of s. Instead of B, you can write 1 by R. Instead of K, you can write 1 by L. Okay, so equation 1 and equation 4 both are similar. They are analogous to each other. Even if you are unable to complete while in your notes, writing this content in your notes, you can later on go through the video and you can copy it down later. Okay, so this is it. Now let us compare these two and just draw a table. If you want, you can draw and write the analogous terms besides to each other. So I'm just changing the slide. So this is it. Just write. No, I want pen. Just write mechanical system and write electrical system. To be more specific, you can write mechanical translational system. Okay, I have written mechanical system. So force is analogous to current. Displacement is analogous to flux. dx by dt is velocity. d phi by dt is voltage. So see, both are V. Don't confuse. Huh? This is V. This is also V. Okay, so you must have clarity. So velocity, dx by dt is velocity. d phi by dt is V, voltage. Okay, so B is analogous to 1 by R. And mass is analogous to capacitance C. K is analogous to 1 by L. And Newton's second law is analogous to Newton's current law. I'm sorry, Kirchhoff's current law. Sorry. Newton's second law is analogous to Kirchhoff's current law, KCL. So this is it. You can copy it down from here to here. The last term, the lever and transformer relationship, we know the transformation ratio in transformers, isn't it? That's what these equations are. No need to write these equations. You write up to Newton's second law and Kirchhoff's current law. Okay, this is the theory part. We have determined the force current analogous elements and force voltage analogous elements. Okay, force current and force voltage analogous elements. Let us solve some numerical problems to understand this concept better. So how to design the electrical system if a mechanical system is given with their analogous elements, that we will see from next slide onwards. Okay, I'm changing this slide. From here onwards, numerical problems, so you should be more careful while listening to the class. This is more important. Okay, this is an important topic. So what is our numerical problem? Write the differential equation governing the mechanical system shown in the figure. Draw the force voltage and force current electrical analogous circuits and verify by writing mesh and nodal equations. Okay, they have asked us to write the both mesh equation and nodal equation. Okay, so this is our given system. You people just copy down the question and draw the circuit. Okay then. So if you observe in this problem, there is M1 and M2. Okay. So two masses are there. So we can say there are two nodes. Okay, two masses means two nodes. So we can write how many force balance equations here. How many force balance equations? Can anyone mention in the chat box? How many force balance equations? Total? Two force balance equations we can write. And here if you observe here at each mass, displacement is mentioned as well as velocity. Okay, V1 is velocity, x1 is displacement, V2 is velocity, x2 is displacement. Displacement as well as velocity is also mentioned here. Okay. So let us start with the free body diagram. So, so let us start with the free body diagram. So free body diagram of mass m1. Okay, free body diagram of what? Free body diagram of mass m1. So this is m1. So in your diagram, if you have drawn it in your notes, you can see there at m1, what is there? Applied force is at the mass m1. Fm1 is the force due to mass m1. B1 is there, so FB1, FB12 is there, and FK1 is there. Okay, so opposing forces. Opposing forces are what? Fm1, FB1, and FB12, FK1. Okay, they are the opposing forces. F of t is the applied force. So if you want, you can if you want to be more specific, you can change the direction of f of t. Okay, instead of see all the directions I have mentioned here in the same direction. Okay, all the directions are same. If you want to be more specific, applied force, you can change the direction. Even if all directions are same, it doesn't matter. Okay, it's not important. So f of t, we already know it is the applied force. Fm1 to Fk1, they are the opposing forces. Okay, they are the opposing forces. So what is the for f? What is Fm1? M1 into d square x1 by dt square. Fb1 is what? B1 into dx1 by dt. Okay. So what is Fb12? B12 into d by dt of what? X1 minus x2. X1 minus, because B12 is between M1 and M2. Similarly, Fk1 is between, K1 is between M1 and M2. So Fk1 is equal to what? K1 into x1 minus x2. Okay. So no, I have written here force, each opposing force equation separately, but there is no need for you to write each opposing force equation separately. Directly, you can write down Newton's second law equation, and in that you can directly write down these equations, but I have written separately. So you people just draw this free body diagram as quickly as possible. If you complete, mention completed. Okay, hope you have completed. So what is the Newton? By applying Newton's second law, applied force is F of t is equal to what? Sum of the opposing forces. What are the opposing forces? Fm1 plus Fb1 plus Fb12 plus Fk1. They are the opposing forces. Now substitute their respective equations. Instead of Fm1, write m1 d square x1 by dt square. Fb1, instead of that, write b1 dx1 by dt. Fb12, you just instead of that you write b12 d by dt of x1 minus x2. Instead of Fk1, write K1 into x1 minus x2, that is equal to f of t. Consider it as equation 1. Quickly write it down. So if anyone, if I am changing the slide, if anyone was unable to write it down, you can later on at least. So someone has mentioned 1 second, okay. So for that person, I will once again show that previous slide. You just draw this quickly. Someone has mentioned 1 second for that person. Draw the free body diagram quickly. Whoever has mentioned 1 second, you just message me as soon as you draw the free body diagram. Okay then. Now if you have drawn free body diagram, you people just write down Newton's second law equations, force balance equation, applied force F of t is equal to what? Fm1 plus Fb1 plus Fb12 plus Fk. These are the opposing forces. Okay. These are the opposing force. This is the applied force. At what? At mass 1. So just replace Fm1 by m1 into d square x1 by dt square, fb1 by b1 into dx1 by dt, fb12 by b12 d by dt of x1 minus x2, fk1 by k1 into x1 minus x2. Okay. So if anyone have network issue, and if even if my voice is breaking, for me I have good internet connection, so for me there is no issue at all. So even if you are unable to, in between, if you miss any content, you can go through this video later on. Okay, it will be available in my channel, so no need to worry. Even if you are unable to, means due to internet connection, in between if you miss any content, you can go through this video later. Okay, completed. Okay then. Now let us draw the free body diagram of this, what is it? Mass 2. Free body diagram of mass 2. So if you see in your actual question main diagram which has been given, there is no applied force at mass 2 m2. So no applied force, all are the opposing forces. What are all the opposing forces at mass 2? Fm2, Fb2, and FB12, FK1 and FK2 are the opposing forces at mass 2. If you have written the question in your notes, you might be knowing this. What is the displacement x2 and velocity is v2? You can mention displacement and velocity also here above this free body diagram. So this is the free body diagram of mass 2. So what is the opposing force? Fm2 is equal to m2 into d square x2 by dt square. Fb2 b12 is what? B12 into d by dt of x2 minus x1, because b12 is between mass 2 and mass 1. So what is Fb2? Fb2 is b2 into dx2 by dt, and Fk1 is what? It is between mass 1 and mass 2. Therefore, k1 into x2 minus x1. What is Fk2? Fk2 is equal to k2 into x2. So just draw the free body diagram and copy down this. These equations, even if you won't copy, it doesn't matter. At least you draw the free body diagram. Directly you can write down these equations in your force balance equation. So completed free body diagram. To conclude this class quickly, so if you complete, please mention in the chat box so that I will change the slide. Okay, no need to write these equations. You can directly write down in the Newton's second law force balance equation. Okay then. So I'm just changing the slide. So by applying Newton's second law, applied force is 0. So 0 is equal to what? Opposing forces. What are the opposing forces? Fm2 plus Fb2 plus Fk2 plus Fb12 plus Fk1. Okay, these are the opposing forces. So what is Fm2? Fm2 is m2 d square x2 by dt square plus b2. Fb2 is what? b2 into dx2 by dt. And what is Fk2? It is k2 x2. And what is Fb12? b12 into d by dt of x2 minus x1. Fk1 is what? k1 into x2 minus x1. Okay. Now this is our equation 2. And we know the relation between the displacement x. X is the displacement, isn't it? X is the displacement. We know relation between x and velocity. What is it? Dx by dt. Dx by dt is equal to what? Velocity. And we already know that dv by dt is what? D square x by dt square. Okay. Isn't it? If dx by dt is v, then what is it? dv by dt is d square x by dt square. And what is x? X is equal to integral of v dt. Okay. So we know the relation between velocity and displacement. What is it? Dx by dt is v. If dx by dt is v, what is x? X is equal to integral of v dt. And what about d square x by dt square? That is dv by dt. So dv by dt is d square x by dt square. Dx by dt is v and x is integral of v dt. This is integral. Okay. This is integral. Okay. So I hope you have completed. I hope you have understood, isn't it? Did you understand this? This you must understand this relationship. Okay. So we have now two equations, equation 1 and equation 2. These two equations are you have written, if you see here in this slide, there is equation 2 is there. You are representing this equation in terms of displacement. Okay. So you have represented. So equation 1 also you wrote in terms of displacement. Now we want to replace this displacement with velocity. Okay. We want to replace displacement of equation 1 and equation 2 with velocity. Okay. We want to replace this displacement with what? Velocity. So just replace with velocity. You try to do on your own. Of course, I will change this slide, but you people try to do on your own. So replace displacement with velocity. So I will just copy those equations also here so that I can compare and I can explain it to you. One second. These two are the equations. Okay. So now just compare equation 1. Just replace x. M1 into, okay, d square x1 by dt square. What is d square x1 by dt square? It is dv by dt. So instead of d square x by dt square, what you must write? This is our equation 1 and 2. Okay. Don't write this. So m1 d square x by dt square. It must be replaced by dv by dt. So d1 v1 by dt. dv1 by dt. B1 you just write as it is. dx by dt is v, isn't it? V equal to dx by dt. So here dx1 by dt is there. Instead of dx1 by dt, write v1 plus v12 is there. So write v12 as it is. D by dt of x1 minus d by dt of x2. D by dt of x means v. So instead of d by dt of x1, write v1. Instead of d by dt of x2, write v2. Okay, plus k1 write as it is. Okay, so this equation we are converting it into this equation. Okay, so this is equation 1. Instead of equation 1, where is the cursor? Equation 1, I am converting the equation 1 into equation 3. Okay, so k1 write as it is. So k1 you write it as it is. Integral of sorry, not integral, x1 is replaced by what? Integral of v dt. So x1 you can replace it with integral of v1 dt, and x2 you can replace it with integral of v2 dt. So instead of integral of v1 dt and integral of v2 dt, integral is taken common. Integral of v1 minus v2 dt they have written, because here x1 minus x2 is there. That is equal to f of t. Okay, so f of t you just keep it as it is. Okay, only x has to be replaced. I will erase all inks. Okay, so what I have done is I have replaced displacement with velocity in equation 3. Equation 1 is changed to equation 3. Similarly, equation 2. Okay, equation 2 can be written in as equation 4 m2. Okay, so m2, this is our equation. M2 will remain constant. D square x2 by dt square will become what? dv2 by dt. b2 write it as it is. dx2 by dt replace it with v2. k2 write it as it is. Okay, x2 x2 is replaced by integral of v2 dt. b12 write it as it is. D by dt of x2. D by dt of x2 is what? v2. D by dt of x1 is v1. k1 write it as it is. x2 can be replaced by integral of v2. x1 can be replaced by integral of v1. That is equal to 0. So I hope I am able to reach you people. Okay. So simply d square x by dt, dx by dt and x must be replaced by their respective velocities. Okay, relation between velocity and displacement I have already shown you in the previous slide. So I will just remove this because anyone, you may get confused, someone who is not listening seriously. So this is what you will get when you replace. Okay, when you replaced displacement with velocity, these two equations you will get. So are you able to understand? I don't know whether I am able to reach you people or not. Our main aim is, we have a mechanical system, we want an electrical system similar to mechanical system. Okay, so we want an analogous electrical system. That's why we have got some equations. Okay, we have written these equations in terms of velocity now. Okay, if you are completed, shall I change this slide? So let us go to force voltage analogous circuit. They have asked us both voltage and current circuits. So let us go for force voltage analogous circuit. I am changing this slide. So let us go for force voltage analogous circuit. So first of all, before designing the circuit, write down the electrical analogous for the elements of mechanical system. So we have mechanical system, isn't it? We have mechanical system. Write down the electrical analogous elements. F of t can be replaced by what? V of t, voltage source. Okay, F of t I have replaced with E of t. E means what? Voltage here. Okay, so if you don't like E, you write V. It doesn't matter. Okay, it doesn't matter. You write E or V, both are same, isn't it? So F of t and is analogous to E of t. M1 is analogous to L1. You already wrote the table in your notes. It is there. From that table, for force voltage analogy, that's table, first table. You just from that you can write down all these terms. B1 is analogous to R1, and K1 is analogous to 1 by C1. K2 is analogous to 1 by C2. B2 is analogous to R2. M2 is analogous to L2. V1 is analogous to I1. V2 is analogous to I2. B12 is analogous to R12. Okay. So this V1 is what? Velocity. V2 is velocity. So this you must write it down. You all of you just note it down in your notes as soon as you complete inform. Now let us design the circuit. Okay, let us design the circuit. Force voltage, electrical, analogous circuit. Let us design it. First of all, in your mechanical system, how many masses were there? In your mechanical system, two masses were there, isn't it? Okay, there were two masses were there in your mechanical system. Therefore, in your electrical system, since it is force voltage analogous system, for force voltage usually you will apply Kirchhoff's voltage law. So there will be two meshes. Two masses means two meshes. So first of all, what you have to do is you draw simply with just a pencil. Draw two meshes like this, which I have drawn here. You draw two meshes. I'm showing you the circuit here. Don't no need to look at the circuit. Just draw two meshes. Okay, I have drawn two meshes here. You people draw two meshes like this. So this is my mesh 1. Okay, why I have drawn two meshes? Because there were two masses were there. So simply with pencil, not with pen, with pencil, lightly, okay, just lightly draw two square boxes. Okay. Now, if you remember, there were elements between mass 1 and mass 2. What were the elements between mass 1 and mass 2? What were the elements between mass 1 and mass 2? You just look at the mechanical diagram. In that diagram, you can see the elements were B12, okay, B12 and K1. B12 and K1 were the elements between mass 1 and mass 2. B12 and K1 were the elements between mass 1 and mass 2. Therefore, what is B12? B12 is R12 and K1 is 1 by C1. Okay, K1 is 1 by C1. So, in the middle branch, what is our middle branch? This is our middle branch, isn't it? You have drawn two meshes now with pencil. So, in the middle branch, what will be there? What will be there? There will be R12 1 by C1. Whenever it is mentioned 1 by C1, capacitance should be connected in series to the other element. So since it is mentioned 1 by C1, connect C1 in series to R12. So draw a resistor here, okay, and a capacitor. Okay, draw a resistor in the middle branch. In the middle branch, draw a resistor and a capacitor. Okay, in the middle branch, you just erase it, you erase the middle line which you have already drawn with pencil, and draw a resistor and a capacitor in the middle branch. You just draw this in the middle branch. Resistor and capacitor, write R12 and C1. Okay. So did you understand how why we are writing R12? Because R12 is analogous to B12 and K 1 by C1 is analogous to K. Okay, K and B12 are between both the masses. Okay, so this is our mesh 1. This is our mesh 1, and this is our mesh 2. Okay, so in between both the meshes, this analogous elements R12 and C1 will come and exist. Okay, yeah, K1 and K1 and B12 were the B12 and K1 were the common for both the masses. So analogous of K1 is 1 by C1, analogous B12 is R12. So in the middle, in between both the meshes, draw R12 and C1. Okay, now, so F of t was the force which is applied to what? To mass 1. So mass 1 means mesh 1. To mesh 1, what is the applied force? F of t. So F of t analogous of F of t is E of t. So draw a voltage source in mesh 1. Okay, draw a voltage source in mesh 1. Okay, what else about the opposing forces for mass 1? Opposing forces were, one was M1. Okay, one force was M1, another force was B1. Okay, another force was B1. Purely it was opposing, it was connected only to mass 1. Okay, B1 and L1, sorry, B1 and M1 were the opposing forces at mass 1. So what is analogous of M1? L1. L1 is analogous to M1. Okay, and R1 is analogous to B1. So connect R and L in mesh 1. Okay, connect R and L, resistor and inductor in mesh 1. Okay, and write L value as L1. I'm sorry, inductance as L1 and resistance R1. Okay, L value L1 and R value R1. Okay, now what are all the opposing applied forces was not there in mesh 2. So forget about it. What were the opposing forces at mesh 2? The opposing forces were M2 and what was the another opposing force? That was B2 and another opposing force was K2. Okay, M2, B2 and K2 were the opposing forces at mass 2. So those opposing forces must be, their analogous must be connected to mesh 2. So what is it? M2 means L2. Analogous of M2 is L2. Analogous of B2 is R2. Analogous of K2 is 1 by C2. Okay. So draw an inductor, resistor and capacitor L2, R2 and C2 connected to the mesh 2. Okay. I don't know whether you people were able to follow or not. If you have understood, you just mention understood. If you have any doubts, if you want me to repeat, I will repeat it. Okay, if you want me to repeat, I will repeat this once again. So simply meshes are replaced by mass in the mechanical system. You consider mass as mesh. That's it. Okay. So instead of if any opposing force is connected to mass, That is its analogous element must be purely connected to the mesh. If any opposing force is between two masses, those opposing forces analogous elements must be connected between two meshes. Okay, so this is the force voltage electrical analogous circuit. Anyone, if you want, if you are unable to understand, you can mention in the chat box. I will repeat. If you have completed drawing it, just mention so that I will go for the next. Now we have this circuit. I forgot this current, isn't it? What is analogous of current? Velocity. Okay, when velocity is current is analogous to velocity. So you just mentioned, since we are considering force voltage analogous circuit KVL, so mention loop currents instead of velocity. Velocity is replaced by current I1 and I2. Loop current I1 and I2. Now you can write the force voltage equations. I'm sorry, not force voltage. KVL equations for mesh 1 and mesh 2. You people write down KVL equation for mesh 1 and mesh 2. What is the KVL equation for mesh 1? KVL equation for mesh 1 is what? E of t is equal to L1 into di1 by dt. I will take the laser. E of t is equal to what? L1 into di1 by dt, I1 by di1 by dt, plus R1 into I1, plus R12 into what? I1 minus I2, plus 1 by C1. Okay, 1 by C1 integral of I1 minus I2 dt. That's it. Okay, what is the KVL equation for mesh 2? KVL equation, there is no source, so 0 is equal to what? L2 into d by dt of I2, RT into I2, 1 by C2 integral of I2 dt, plus 1 by C1 integral of I2 minus I1 dt, plus R12 into I2 minus I1. This is, am I clear? You can write it in, see, you have drawn the electrical circuit. If you have understood how to draw, later on applying KVL, okay, you can write down the mesh equations or loop equations. These are the equations. So these are the loop equations. L1 into di1 by dt plus R1 I1. So you can compare this equation 5 and equation 6 with 3 and 4, which you have already written. Both will be similar to each other. Okay, just compare it. If you have completed, mention so that I can go for force current and electrical analogous circuit. You just compare it. I hope you have understood. Now let us go for force current analogous circuit. If anyone have not yet written those equations, you can mention in the chat box. I will go back. Okay. Now, first of all, we already know the electrical analogous elements, isn't it? Okay. So you just write down the analogous elements from the table which you have already written. So f of t is analogous to I of t, or I of t is analogous to f of t. Analogous of m is c1. Analogous of b is r, 1 by r, sorry. So b1 is 1 by r1 is analogous to b1, 1 by l1 is analogous to k1, and 1 by l2 is analogous to k2. 1 by R2 is analogous to B2, 1 by C2 is analogous to M2, voltage is analogous to velocity, V1 is analogous to V1, V2 is analogous to V2, means voltage is analogous to velocity, 1 by R12 is analogous to B12. So what you have to do is, whatever mechanical equation terms are there, you have already written equation 3 and 4, isn't it? You write all the terms of 3 and 4. From the table, write on their analogous terms. Okay, I will just go back to the previous slides. What you have to do is, you have to write M1 and put an arrow mark, leave it. M2, put an arrow mark, leave it. You write V1, put an arrow mark, leave it. Write B1, B2, B12, K2, V1, V1, B2 is over, okay. B12 is also over. K1, here also K1 is there, okay. Whatever terms are there, f of t, all these terms you just write and leave it, and after that in front of them from the table, okay, write all those terms, okay, f of t, v1, v2, m1, m2, b12, b1, b2, k1, k2 from equation 3 and 4, and after that from the table write their analogous terms. These are the analogous terms. Okay, so what you have to do, you just take the equation 3 and 4. From the equation 3 and 4, whatever terms are there in equation 3 and 4, write down all those terms. And from the table, which you have drawn already, from that table, copy their respective analogous terms. For force voltage or for force current analogy, first of all, what you have to do is, once again, I'm repeating, I don't know whether you are able to follow or not. First of all, what you have to do is, you have to take these two equations. Okay. You just take these two equations and write down all the terms. F of t is there, write f of t. M1, write M1. M2, write M2. B1, write B1. B12, write B12. Okay, K1, write K1. V1, write V1. V2, write V2. And what is left over? K2, write K2. B2, write B2. Okay, K1 we have already written. Okay, so all these terms you just write it down, and later you write their analogous terms. Okay, you know how to write those equations already. So I hope you have completed. Now you know the analogous terms. So how many masses were there? Two masses. Since there were two masses in the given mechanical system, there will be two nodes in force current analogous system. Two nodes will be there. Okay. So two nodes will be there. So what you people have to do is, okay, just mention two nodes. Node 1 and node 2. Okay, mention two nodes. You can write down their node voltages V1 and V2 at those nodes. Okay, so we already know in the previous slide V1, V2 is there. So you can write down those node voltages V1 and V2. Okay, so just put a dot here, put a dot here. Okay, and write down V1 and V2. Now in between nodes, okay, in between masses, what was common? In between masses, what was common? Okay, in between masses, what was common? The common elements were B12. So the common elements were B12 and what was it? K1. K1 and B12 was common for both the masses. So what is the analogous of B12? Analogous was 1 by R12. Analogous of K1 is 1 by L1. So 1 by R12 and 1 by L1. Since it is mentioned 1 by R12 and 1 by L1, both R and elements R and L should be connected in parallel. Remember one thing, if a resistor and inductor are represented by 1 by R or 1 by L, you must connect them in parallel. If capacitor is represented by 1 by C, you must connect in series. That is important. Okay, that you must remember. If capacitor is represented by 1 by C, you must connect in series. Capacitor should be connected in series. If resistor and inductor are represented by 1 by R and 1 by L, you must connect them in parallel. If resistor and inductor, if they are represented by R and L, then you must connect them in series. If capacitor is represented by C, then you must connect in parallel. Okay. So 1 by C means series. C means parallel. 1 by R means parallel. R means series. So here, what is there? In the previous slide, I will show you the previous slide. What is there? Here, B1 is 1 by R1. And K1 is, our terms are in between two masses. What was there? K1 in between two masses. K1 was there and B12 was there. So B12 is what? Analogous of B12 is 1 by R12. Analogous of K1 is 1 by L1. So connect L and L1 and R12 parallel to each other in between V1 and V2. Did you understand? Within 5 minutes, I will conclude this topic. I will stop this lecture. Okay, only 5 minutes. Maybe 5 minutes or 5 to 10 minutes because I am explaining this circuit. As soon as this explanation is over, I will stop. So, okay, R12 and L1, they must be connected in parallel to each other in between V1 and V2. Here V1 and V2 are the node voltages. So nodes represent the masses. Mass is replaced by what? Nodes here. So now, only to node 1, only to mass 1, what is connected? F1 is connected. F of t is connected. So F of t, okay, F of t must be replaced by what? I of t. Okay, parallel to I of t, M1 is also connected to only mass 1. So connect parallel to it to M1 analogous is C1. So connect C1 to node V1. Connect I of t to node V1. I of t means F of t. C1 means M1. And one more term, that is B1. So F of t, M1 and B1 are connected to mass, are the F of t is the applied force, M1 and B1 are the opposing forces. So connect C1, R1 and I of t to V1. Now go to node 2, that is mass 2. Go to node 2, this is node 2, this is node 1. Isn't it? This is node 1, I will take the laser. This is node 1, this is node 2. Now go to node 2. Node 2 means mass 2. So there is no applied force at mass 2, opposing forces. So what are the opposing forces at mass 2? M2. So connect C2 to mass node 2. Next, Another opposing force at mass 2 is B2. Connect R 1 by R2 is analogous to B2. So connect R2 to node 2. Next, another opposing force is K2. So connect 1 by L2 is analogous to K2. So connect L2 to the node 2. Now join all these elements together. Okay, join I of t C1 and R1 at a common point. Join C2, R2 and L2 at a common point and join them together. Okay, so all the elements, these elements are connected. This is force current analogous circuit. So elements should be not they are not should be, I can't say should be, but usually you will get all the terms connected in parallel for force current analogous circuit. Okay, so here node 1 represents mass 1, node 2. If you want, I can write. Okay, this is our node 1, NOD node 1. This is our node 2. So in between node 1, so node 1 means mass 1, node 2 means mass 2. Okay, node 2. So this is node 2, this is node 1. Node 1 means mass 1, node 2 means mass 2. In between mass 1 and mass 2, what is connected? In between mass 1 and mass 2, B12 and K1 are connected. So B12 is what? B12 can be replaced by 1 by R12. K1 can be replaced by 1 by L1. Since resistor and inductor are represented by 1 by terms, therefore they should be connected in parallel. So R12 and L are connected in parallel between node 1 and node 2. So only to node 1, only to mass 1, what is connected? Applied force. So that is I of t. Opposing force C1 and R1. C1 means M1, R1 means 1 by R1, that is 1 by R1 is B1. So only opposing forces are there at mass 2. So that is at node 2 only opposing forces will be there. What are the opposing forces? So one is M2. At mass 2, what are the opposing forces? M2. Other one is B2. Other one is K2. So M2 means C2. B2 means 1 by R2. K2 means 1 by L2. So connect all this to the nodes and their other terminals connect to a common node and the other terminals connect to a common node and join it. Are you able to understand? Do you want me to repeat? I have repeated twice till now. Were you able to understand? I am about to finish. I am about to finish. Were you able to understand or not? Do you want me to repeat? Okay, no one is responding. It's okay. So now write down the nodal equations at node 1. This is node 1. Pen, I have taken pen. This is node 1. This is node 2. Write down nodal equations, Sama. So what are the nodal equations that you can write at node 1? What is our nodal equation? I of t. I of t is equal to what? I of t is equal to C1 into dV1 by dt. Okay. Plus 1 by R1 into V1 plus 1 by R12 into V1 minus V2 plus 1 by L1 into integral of V1 minus V2 dt. That's it. Nodal equation at node 1. Similarly, nodal equation at node 2. Okay, at node 2, applied here there is no source. So 0 is equal to C2 into d by dt of V2 plus 1 by R2 into V2 plus 1 by L2 integral of V2 dt plus 1 by R12 into V2 minus V1 plus 1 by L1 integral of V2 minus V1 dt. Okay, so simply applying nodal means applying Kirchhoff's current law. Whatever equations that you can write, those equations I am telling you now. So just write down these two equations. If you have completed, mention completed. You can compare these two equations with the mechanical system. I will write down those. I will copy those two equations here. I am about to conclude. Now you can compare 7 and 8 with equation 3 and 4. Okay, you just see C1 dV1 by dt, M1 dV1 by dt, 1 by R1 V1, B1 into V1, 1 by R1 to V1 minus V2, B1 to V1 minus V2, 1 by L1 integral of V1 minus V2 dt, K1 integral of V1 minus V2 dt, I of t, F of t. That is our equation 3. Equation 3 is same as equation 7. And similarly, compare equation 8 with 4, C2 dV V2 by dt, M2 dV2 by V2 by dt, 1 by R1 V2, B2 V2, 1 by L2 integral of V2 dt, K2 integral of V2 dt, 1 by R1 to V2 minus V1, B1 to V2 minus V1, 1 by L1 integral of V2 minus V1 dt, K1 integral of V2 minus V1 dt equal to 0, isn't it? Equation 3 is similar to 7, equation 8 is similar to 4, isn't it? So, we can say that these 7 and 8 are analogous to equation 3 and 4. So, you can write a statement. The node-based equation 7 and 8 are similar to the differential equation 3 and 4 governing the mechanical translational system. You can write this. Okay. Thank you for joining the class. If you have any doubt in this, you can just mention in the chat box or clarify the doubt regarding this topic.